Okay, so here's another section that's straight out of your Algebra 1 textbook. So the plan is going to be just to run through a bunch of examples, and then in class let you work independently, and that way if there's anything you're really not understanding, I kind of talk to you one-on-one. So 3.4 equations of lines. We're just going to find equations of lines. We talked about slope in section 3.3, so now we're going to be able to find equations of lines given certain information and data about what's going on. First thing, non-vertical line equations. The two forms you should be familiar with from Algebra 1, slope-intercept form, y equals mx plus b, and point-slope form, y minus y1 equals m times x minus x1. For both of them, okay, m is always the slope. Both of them have m in the slope, so if the slope is 3, we have 3. Where things are different at is if you already have the y-intercept, you can just plug that in for b into the equation. If you have the slope but you don't have the y-intercept, then you need a second point. All right, not a second point, but just a point, maybe, depending on the problem. And once you have that, then you can plug the y value in for y1 and the x value in for x1. And then what we will do is we'll just distribute and write it in slope-intercept form afterwards. That's the traditional way to kind of do this. Okay, so it's going to be a little bit longer video, but basically everything breaks down to finding equations of lines, given some information. So here's the first example. Write an equation of the line in slope-intercept form of the line, or write an equation in slope-intercept form of the line with a slope of 6 and a y-intercept of -3, and then graph that line. Okay. So here we go. So I've got this problem here. So if it's going to be slope-intercept form, which is what they want me to use slope-intercept form, okay, that is going to be y equals mx plus b, where m is the slope, b is the y-intercept. Now, the thing about it is and the reason they want us to do it this way is they've given us the slope. The slope was 6. The y-intercept was -3. So I know m is 6. And if I want to make it a fraction, 6 over 1. And b is -3 since that's the y-intercept. So the equation is y equals 6x minus 3. Now if I'm going to go graph this, I need to plot my two things here. My y-intercept first, and then my slope. So to graph a line, the first thing you do is you plot, to graph, plot a point. But in this case, we're going to plot the y-intercept. Okay, so the y-intercept is at -3, so I'm going to go to the y-axis and go down. And again, this is y, this is x. Okay, so I'm going to go to -3 on the y-axis. 1, 2, 3, plot a point there. And then plot the slope away from the point. My slope is 6 over 1, which there are two ways I can write that. It can be +6 over +1, which means you're going to go up 6, right 1. Or it could go -6 over -1, which means down 6, left 1. So from here, okay, go up 1, 2, 3, 4, 5, 6, right 1, so up 6 over 1. And then go down 1, 2, 3, 4, 5, 6, left 1. Okay. And now that I have 3 points, take my ruler out, sketch my line. There we go, y equals 6x minus 3. Okay, first example. All right, next one. I think it's just gonna boom, 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 move through them. Okay, so write an equation in its point-slope form of the line whose slope is -3/5 that contains -10/8, and then graph the line. All right, so again, going back to the screen here. Okay. Now it says point-slope form. So point-slope form is y minus y1 equals m times x minus x1. All right, and where m is the slope again, and then x1, y1 is the ordered pair. So our x1 is -10, our y1 is 8, our slope is -3/5. So y minus y1, which was 8, equals the slope, -3/5, times x minus x1, which is -10. So y minus 8 equals, I'm going to make that plus 10 just so I can cancel that off. And it's in point slope form right here actually, but I'm going to go ahead and transfer to slope intercept just to graph it. I should have said that, so sorry, yeah. So here it is point slope form, but to graph it, it's easiest to graph it as slope intercept like we've done the previous. So distribute the -3/5 to both of those, so it's -3/5 x, and the -3/5 times 10 over 1, That cancels to be 2 and 1, minus 6. Okay, and then I'll add 8 to both sides. So y equals negative 3/5 x plus 2. Okay, so again, this is slope-intercept. I should put this slope-intercept form. Point slope form, since that was the directions, y minus 8 equals negative 3/5 x plus 10. And now, again, to graph it, the first thing we're going to do is plot the y-intercept. So our y-intercept is 2. So we'll start at positive 2. Okay. Then our slope is negative 3/5. Now, with the slope being negative, that means it's a negative over a positive, or it's a positive over a negative. Okay. So from here, I'm going to go down 3, right 5, or I'm going to go up 3, left 5. So from here down, go 1, 2, 3, right 1, 2, 3, 4, 5, or go up 3. And again, you go back to the y-intercept again to start the second point. Technically the third, because we've already got 2, but the second point for the slope. You go up 1, 2, 3, left 1, 2, 3, 4, 5, and then graph our line. There we go. All right. Next example. Okay, next example. Write an equation of a line in slope-intercept form for the line containing the points 4, 9, and negative 2, 0. All right, now to knock this one out, here's the deal. When finding the equation of a line, because the two previous ones, they told us what to do, they gave us everything we needed. This one, we're missing something. We're missing the slope. So to find the equation of a line, the first thing you have to do is find slope. You always have to find that first. Well, luckily for us, we have 2 points, so to find our slope, we just use our slope formula. So y minus y, I'll call this, x1, y1, x2, y2. It doesn't matter which point you call x2 or x1, which order pairs which, the first or the second, but I ordered it. So 0 minus 9 over negative 2 minus 4. That gives me on top negative 9, gives me on bottom negative 6, which is 3/2. So I have the slope of 3/2. All right. Now, this said slope-intercept form. So it doesn't matter if we start off with slope-intercept or we do point-slope form, although I tend to be kind of traditional and I always use slope-intercept. So I've got my slope. Okay. It is it's 3/2 x. It's 3/2. So the equation then is y equals mx plus b in slope-intercept form, or y equals 3/2 x plus b. And at this point, we have to make a decision. Now, luckily for us, there's not a wrong decision, but there still is a decision to be made. I have to choose one of these points here to solve for b. You might be saying, well, how does that help me out? Well, if I look at this, what do I have here but an x and a y? And what I can do is plug in 4 for x, 9 for y, and that'll allow me to solve for this missing guy b in the equation. So here we go. Plug in 9 for y, plug in 4 for x, and then just do the arithmetic. 9 equals 3 over 1 times 2 over 1, which is 6, plus b, subtract 6. The y-intercept is 3. So my line is now y equals 3/2 x plus 3. Okay. Now, if you'd use this point over here, it'd be the same thing. It would solve the exact same way. We'd still get 3 for the y-intercept. You could have also done point slope, where you said, okay, y minus y equals the slope over x minus x, and use this point here, and just done all the point slope business. It would give you the same thing. This would just drop away because y minus 0 is y. Distribute to that, we get y equals 3/2 x, and then 3/2 of 2 is 3. So either way, it doesn't matter how you go about it, but this is the way I traditionally do it. I solve for b and then plug it back in. Okay, next. So we kind of went through all that, and in class you'll again have examples of doing those problems. So make sure you took detailed notes. If you need to, go back and rewind it and watch me do it again. But next, Horizontal and vertical lines. Okay, this always seems to throw people off. It gets confusing as to which line is horizontal and which line is vertical. So I'm going to go to my little drawing here to kind of talk about this. So if you need to go back to the video and just pause this to fill in the stuff, and then come back and watch me go through it. So the equation of a horizontal line is y equals b, where the y-intercept of the line, where b is the y-intercept of the line. Well, this should make sense. We talked about this yesterday, that if you have horizontal lines, you have a slope that's 0, which means you're talking about y equals 0x plus the y-intercept if you do slope-intercept form. Hey, what's 0 times anything? Nothing. So it's y equals b. Plus, and this is the other way to think of this, if I take a bunch of random points off of this line, I just highlighted 3 of them in blue. This point here is negative, this is 0, 0. This point here is negative 1, negative 3. Negative 3, negative 3. This point here is 0, negative 3. This point here is 2, negative 3. Notice what's the same for all these? On all 3 of these ordered pairs, the y's equal negative 3, hence the equation y equals negative 3. Now, for vertical lines, I can't do slope-intercept form because a vertical line has a slope, we talked about this, yes, on 3.3, that's undefined. So if I tried to plug in, undefined number for slope, it falls apart. I can't do undefined times a value. So that's why it's just simply x equals something. Also, if I just pick, again, 3 random points off this line for the vertical one, it's negative 2, 3, negative 2, 1, negative 2, negative 2. Notice, for this guy, all of the x's stayed the same. All 3 of those x's are negative 2, which is why the equation of that line is x equals negative 2. Okay. So when you're finding a horizontal or vertical line, it's going to have 0 slope for horizontal, undefined slope for vertical, and then it's just x equals whatever for vertical, whatever the x's are, y equals whatever for the horizontal. Okay. All right, now, not the last thing here, but some of the last bits of this section. Okay, make sure I haven't skipped anything in my video. Yeah, so write an equation in slope-intercept form for a line perpendicular to the line y equals 1/5 x plus 2 to the point 2, 0. Okay. So again, in order to find the equation of a line, the first thing I have to do is find slope. Okay. Well, when I look at this, the question is, what's the slope? Well, the slope, if this is in slope-intercept form, which it is in slope-intercept form because it's y equals something times x plus a number, this slope is 1/5. Okay. Now you might be saying, why do I care about that 1/5? Well, wait a second. It said write an equation in slope-intercept form of a line perpendicular to this line. So I need to know the slope of this line to find perpendicular slope. Now we did perpendicular slope again in section 3.3. 2 lines are perpendicular if their slopes are opposites and reciprocals. So if my slope here is 1/5, the perpendicular slope will be, first of all, not positive but negative. And then what's reciprocal of 1/5? 5/1. So my slope is negative 5. Okay, so I've got that. Y equals negative 5x plus b. Now the second part then is find y-intercept. Now again, I could use point slope form, or I could just do the process we did earlier with plugging in 2 for x and 0 for y, and then I could solve for b. So that's what I'm going to do. I'm going to plug 2 in for x, plug 0 in for y, and solve for the b. So 0 equals negative 5 times 2, because again 0 for y, 2 for x, plus b. 0 equals negative 10 plus b. Move 10 over. B is 10. So now I know my slope, negative 5. Now I know my y-intercept, 10. Y equals negative 5x plus 10. There we go. Okay. All right, last example is actually a two-part example, just to make sure of this, though, that I haven't skipped anything. Yep, here we go, rental costs. So an apartment complex charges $525 per month plus a $750 annual maintenance fee. Excuse me. Write an equation to represent the total first year's cost, A, for R months of rent. Okay, now, here's what we have to realize. For a line, if I go back to slope-intercept form, it's y equals mx plus b. Well, what is m really? M is the slope, but it's also your rate. Okay, it's your rate. And what is the b? Well, that, if I go back to the graph real quick, I find my sheet here, what I did a minute ago when we graphed. The y-intercept, that too, that it wasn't this problem right here, the y-intercept is the starting point. It's where I started this line at on the y-axis. Okay, so when I use slope-intercept form, I can think of the y-intercept as the starting point. So looking at this then, I want to know what's the rate and where does it start at? Well, in our case, it's hopefully kind of obvious. The rate is the $525 per month. Okay, and the starting fee, that might seem kind of strange. I mean, your guess is $750 because it's there, but if you stop and think about it, let's say you don't pay for your apartment for any months for some reason, which seems possible. But let's just say you did that. You would still owe $750 regardless, just to pay for the maintenance. So that's going to happen one time a year. This is going to happen monthly. So this is your slope. This is your y-intercept. Now, they did give us x and y. They gave us a and r. So we have to replace y and x with some variable. So it says write an equation to represent the total first year's cost. Here we go. That's the total after r months of rent. Okay, that means the total is y, because y is the total cost at $450 per month plus the initial amount. Plus, if r is months, if I do dollars per month for the slope times r months, the units cancel. And I just get dollars, which is what I want to talk about, because then I'm going to add to it the starting point, which is dollars. That's total cost. Okay. So our equation then is the total cost, which is A, is $525 per month times the number of months, which is R, plus the $750 that we have to pay just to begin with. Okay. Now part B then says, okay, you've got that equation. Now what I need you to do is to use that equation. So compare this rental cost to a complex which has a $200 membership but $600 a month per rent. If a person stays at this complex for 1 year, which one offers the better rent? Okay, well, here's the deal. This is the same thing, except for this guy is going to be, whoops, I'm out of space, $200 for the annual rent and $600 per month. So he'll be $600R plus $200. And what they want is to compare which one's better for a year, which means I need to plug in 12 for R, because that's how many months are in a year. Okay. So this one is A equals 525 times 12 plus 750, which I'm feeling lazy and we're running short on time with this because it's going long. I'm just going to plug 525 times 12 in. And then add 750. Okay. So this guy for a full year is $7,050. Okay. The other one, is going to be 600 times 12 plus 200. So 600 times 12 plus 200. 7,400. So even though this guy has the lower annual maintenance fee, but because it's a little more expensive over the course of the year, it actually ends up being a lesser, more expensive apartment. So we'd really want to go with the 7050. Okay. All right, so that's that. Like I said, in class you'll have a bunch of examples to work through. They'll all be very similar to this. So there'll be maybe a few weird twisted here and there. But for the most part, everything's covered here in the video, so it'll be a lot of individual work in class. So if you do have any questions, though, any of these did not make sense, come in and see me see me before school tomorrow morning, and I can probably go through and clear a lot of these issues up. All right, thanks.